Okay, let's dive right into this. Welcome to today's explainer, where we're tackling a pretty massive goal: demystifying Moonshot AI's highly anticipated absolute behemoth of a new model, Kimi K3. If you've been keeping tabs on the frontier of open intelligence, you already know this release is a total game changer. We're going to break down exactly what this model is, what it's actually capable of, and most importantly, how you can set it up to start working for you in under 10 minutes. But first, a really quick clarification. Section 1, not that Kimi. If you've been glancing at the news lately, you might have seen the name Kimi making headlines for a totally different reason. And no, we are not talking about Formula One driver Andrea Kimi Antonelli, though the contrast here is honestly just too good to ignore. Over in the F1 world, Antonelli just faced an investigation at the Hungarian Grand Prix. He caught a three-place grid drop for going a mere 3 kilometers per hour too fast while passing a yellow flag incident involving Max Verstappen. The F1 stewards ruled his attempt to slow down was insufficient and unsustained. But the Kimi we are talking about today, well, it just dropped 2.8 trillion parameters on the AI ecosystem, and its compute capabilities are accelerating with absolutely zero limits. There is no lifting off the throttle here. So, let's leave the racetrack behind. Section 2, meet Kimi K3. We aren't just talking about a minor incremental update here.
The sheer scale we're dealing with is a fundamental leap in open source architecture. That number is 2.8 trillion. Kimi 3 is officially the world's first open 3T class model. It marks a really sustained push by Moonshot AI at the scaling frontier, effectively setting a massive new upper bound for open model sizes.
And to pair with that massive brain, we have an equally massive memory. Kimi K3 features a 1 million token context window. Just to put that into perspective, that's roughly 750,000 English words. You can literally feed this model entire books, extensive project histories, massive code repositories, and hundreds of pages of research all in a single prompt. This context window makes complete sense when you look at the leap from the previous generation. Compared to the older K2.6 model, we're seeing a 4x leap in the context window alone. But the absolute crucial point is the underlying architecture. K3 is built on the new Kimi Delta Attention, or KDA, alongside attention residuals. This means K3 is expressly designed to handle heavy memory tasks, deep analysis, and complex reasoning over immediate, simple speed. You wouldn't really use this for a quick chat. You use this when you need a serious intellectual heavy lifter.
Which brings us to Section 3, Kimi's mind-blowing creations. Let's look at the real-world autonomous AI this model has already built.
Just take a look at these 3 wild examples. First, as a proof of concept, K3 actually designed a microchip. In a single 48-hour autonomous run using open-source EDA tools, it built, optimized, and verified a chip on the NAND-Gate 45nm library, a model designing a chip to serve a model. Second, it built a fully procedural 3D open-world horseback riding game right in the browser using Three.js, web GPU, complete with weather and environments. And third, for the scientific community, it reproduced complex I love Q universal relations in computational astrophysics. It cross-validated over 20 papers, identified math errors and published formulas, and generated 3,000 lines of Python code for an interactive dashboard. And it did that in 2 hours. A human researcher would take 2 weeks to do that. And it doesn't stop at text and code. K3 has a native multimodal architecture. It literally edited its own promotional teaser video. It took 56 source clips, handled the clip selection, matched the cuts to motion, and perfectly synced the visuals to the audio beat with frame accuracy. It did the job of an experienced human video editor in a fraction of the time. Section 4, built for agent loops. All of these incredible creations, the chip, the game, the video, the research, they weren't made by a human constantly clicking and prompting every 5 seconds. They were built using something called agent loops. So the vital point here is understanding this definition. An agent loop is the difference between asking an AI a question and waking up to finished work. It's basically the oldest idea in programming applied to the newest tool. K3 isn't just a chatbot. It's designed to run continuous, supervised turns. It profiles, it writes, it tests, it reviews its own errors, and it fixes them, looping over and over until the goal is completely met. And because of that 1 million token window and its multimodal nature, you can connect text and images simultaneously inside this loop. You can feed K3 screenshots of a broken website layout alongside the raw code and your written instructions. It achieves vision in the loop by iterating between reading the code and reviewing live visual outputs, refining the work exactly like a human developer would. Section 5, your 10-minute setup guide. Now, I know what you're thinking. This sounds incredibly advanced. How do I even get access to this? Well, here's how you can deploy K3 yourself instantly, in under 10 minutes. First, you can skip the complicated local installations entirely. Just open the official Kimi website or their mobile app and create a free account. Second, and this is super important, open the model picker in the chat and manually select K3. Sometimes the interface defaults to an older, faster model like K2.6, so make absolutely sure K3 is active. Third, feed everything up front. Give it your documents, your screenshots, your entire code base. And finally, write a prompt with a clear, checkable goal. Don't just say, make this better. Say, run a lint pass and fix all failing tests. To get the absolute most out of it, definitely keep these pro tips in mind. The biggest mistake you can make is sending a large project in tiny pieces. That completely wastes the million token window. Also, expect longer thinking times. This is a reasoning model. It is literally working through complex logic, so be patient. Save your free message allowance for heavy, deep context tasks. Use the older models for your quick questions. And if you're a power user, create a dedicated K3 profile in your central workspace, your agent OS, like Hermes or Claude Code, to automate those repeat workflows. For the developers tuning in, there's actually a dedicated path just for you. You can run the Kimi Code CLI directly in your terminal. Just type /model to select K3, and you can plug this frontier intelligence straight into your coding agents. This lets you automate your SEO, sales, or lead generation workflows 24/7 without ever even having to leave your IDE. Section 6, the Open AI Frontier. Let's look at how all of this builds towards the future of open intelligence, because it's not just about the raw power of the model, it's about the economics of running it. Historically, people avoided building agent loops because running 100 iterations on a massive frontier model cost an absolute fortune. But look at this pricing structure from the Kimi API. Because of K3's advanced caching system, specifically their prefill cache implementation, a cache hit input is only 30 cents per million tokens. The official API is hitting over a 90% cache hit rate in coding workloads. This makes running complex multi-step agent loops remarkably cheap. K3 essentially just made the agent loop economically viable for the everyday builder. Which leaves us with one incredibly exciting question. What will you automate when you can spin up a 2.8 trillion parameter brain on your desktop for pennies? The barrier to entry for frontier intelligence has literally just been obliterated. Whether you're generating complex research reports, editing videos, or building entire pieces of software from scratch, the tools are now right there in your hands. Thank you so much for joining me on this explainer. Go set up your workspace, start building those loops, and I'll see you in the next one.